안녕하세요 여러분, 해리입니다. So in this video, we're going to learn exponential and logarithm. So we're going to start with exponential first. So exponential, as what we have learned in the secondary school math. So if we have a to n, we call this as the base, and we call this as the power or exponent, right? But what does a to n mean? So it means that we are multiplying a n times, right? So if we multiply a like repeatedly many times, then we can just put a power on it, right? So the first properties of exponential we have is a to 0 equals to 1. So a to 0, what does that mean? It means we're multiplying a 0 times, right? Multiplying a 0 times, but where are we multiplying it to? That means we need a background. And the background for multiplication is 1 because it does not, so if you multiply 1 with any number, we have that number, right? And if we multiply 1 like infinitely many times, it's still 1. So the background for multiplication is 1, and we call it as multiplicative identity in the formal mathematical term, but you don't need to know this term, but just be aware that the background for multiplication is 1. That's why a to 0, that means from 1, from the background, we are multiplying a 0 times. That's why we have 1, okay? Second thing we have is that if we have a to negative 1, we have 1 over a, and this is because negative 1. So in order to understand this, so we need to, so I'll explain the other properties first and then I'll come back to this. So if we have a to m times a to n, what does that mean? That means we are multiplying a m times, and we're multiplying a n times together. Then total, there will be m plus n a being multiplied, right? And we have the other property, a to m divided by a to n. Now, so this one, a to m means we're multiplying a m times, and a to n, we're multiplying a n times, right? But if we're dividing a to n from a to m, right? That means we're multiplying a m times, and we're dividing a n times. So we're basically canceling a's, right? So we can have a to m minus n, and that's why if we have minus, we put it as the reciprocal, okay? Because it's simply meaning that it simply means division, okay? So the fifth property we have is that what if we have a to m and then to n? Then it's just this. Why? For example, if we have 2 to 4 squared, that means we are multiplying 2 to 4 twice, right? But how many 2 are we multiplying in each 2 to 4? 4, right? 4 and 4, that means we are multiplying 2 8 times. So we have 2 to 8. That's what it means, okay? So, and one last thing. So if we have a to 1 over n, we say that it's the nth roots, or a to 1 over n, okay? So using this property 5, we can expand this into this case. So that means a to m to 1 over n, right? That means this, okay? So that's it for exponential properties. So it's just recall the definition, okay? A to n, it means we're multiplying a n times. So if you just remember that, then you can drive everything. Maybe not this, but yeah, for almost every properties, you can easily understand it, okay? Then I'll give you a question. So the questions for exponential using the properties will not be hard, but I'll let you try in the sample test a lot because I don't want to spend too much time on the simple things. So an example of exponential we can have is an exponential equation. So let's say we have 2 to 2x minus 3 to 3 times 2 to x plus 2 equals to 0. So far what we have been doing is solving polynomials, right? So quadratics, linear, or for HO, cubic and quadratic and so on, right? But now we have an exponential equation, and a lot of students may feel this is unfamiliar. So what we can do is that first, let's try to apply this to here. That means we can write it as 2 to x squared minus 3 times 2 to x plus 2. So we can treat 2 to x as a subject, right? In other words, we can make a substitution. Let a be 2 to x. Then what is this? It's just a simple quadratic, right? And we can very simply factorize this. So a equals to 2 or a equals to 1. But what's a? A is 2 to x. So 2 to x equals to 2 or 2 to x equals to 1. So x equals to 1 and x equals to 0. But what if, so for another another examples with something like this, you may have like let's say for example a as -3 and a as 2, right? Then 2 to x equals to -3 and 2 to x equals to 2. Do you think this makes sense? The base is 2. Then no matter the power is, so what does this mean? We're multiplying 2x times, right? So we're just basically multiplying positive numbers only. But how can that be negative, right? So we reject this case, okay? And we all just consider this case, okay? So this is how you can evaluate and then reevaluate based on the restriction, okay? Now let's move on to log. So I'm going to talk about this in the functions chapter, but please be note that log and exponential are in real inverse function relationship. So but before that, let's just understand what log is. So log, we can write it as this, and this we can write it as exponential as well. So that one is the base for log, and again, and it's the base for the exponential as well. So if we have something like this, then we can always write it like this. So you can see that the entire log value, this one, which is y, is just the power or exponent. And this x here is just the exponential value, the entire exponential value, okay? So using this, we're going to understand some of the properties. And about the notation, so in IB, if we have no base, that means the base is 10. So we're just omitting it. And if we have something like this, which is called the ln, so ln x, that's the natural log x, where the base is e. Then what is e? So e is a natural constant, and at the same time it's the fundamental constant of calculus, and it's 2.71 and then so on, and it's an irrational number like pi. For formal definition, this is e. So when you add a very, very, very small number to 1, and if you multiply that infinitely many times, then we will have this constant e, okay? But you don't have to know this definition for SL and HO, because, well, for HO calculus option, you have to know this. But yeah, just this is the derivation of e, okay? Alright, so based on this, we can understand some of the properties. So let's start with this. Alright, so log base A xy. So you can see that, remember, the thing inside is the exponential value, right? Then we can treat x and y as two different exponential values. So the exponential values of x, so x as one exponential value and y as another exponential value, like this. So this x is the exponential value, right? And they're being multiplied together. And then what happens to the power? Remember, two exponential values being multiplied together, we add the power, right? So what we can do is that we can add the power of x and we can add the power for y. Okay? A lot of students make this mistake. Then what about this? So later, when you see this, some say this. No. What does this mean? We are adding two different exponential values. For example, a to m plus a to n. Can we do anything with this? No, unless we can factorize it by like same number of a being multiplied. We cannot do anything, right? We cannot do anything to the power. That's why this one doesn't have a formula, so it doesn't have a specific rule, okay? So log base a x plus y is just log base a x plus y. We can't do anything, okay? 3, if we have a division of two exponential values, then see, two exponential values division, then we subtract the power. And note that log, value of log is power, so we are subtracting x and subtracting y, because log base ax, that gives us the power for x and power for y. So we are subtracting the two powers. Okay? That's how we can understand. So similarly, if you have x minus y, then you can see that it's just a to m minus a to n. So except for just simple factorization of common factor, you can't do anything. So there is no fixed rule for these two. Okay? Alright, so the other property is this. Log base a x to n. So this one, we can simply write it like this. And I'll tell you why. Because x to n, right? If we consider x to n, that means, so for example, if x is an exponential value like this, right? So it should certainly have a certain power with a base a, right? Then we can write it as a to something to n, right? And remember, we can multiply the two powers together. And this square here should be the power of this exponential value a. That's why we are simply multiplying the power of x and n. Okay, that's why we can have this. All right? Or, so log base a x to n is simply log base a x times x times x times all the way to x, where we multiply x n times, right? And we basically apply this second property. So log base ax plus log base ax plus log base ax plus all the way until log base ax, and we have n terms, right? So that's why we have this. Okay, we can still use this method to prove it, but you need something else that I haven't taught yet. That's why I'm not gonna prove it in this way. Okay, next one we have is log base a1, which is 0. And this is because if you make it into exponential form, this is always true, right? Unless a is 0, which is undefined. But we for exponential or log, I'm gonna talk about that in function chapter later. But note that the base for log cannot be 1 and is always greater than 0. So for exponential, so I should have taught this first. So a has to be greater or equal to 0 because we don't consider negative number for a case like this. So if n is 2, then a to 1/2 is root a, right? But if a is a negative number, then it's root a negative number, right? So it's undefined in real number set. So we have this restriction, and for log, we have the same restriction because it's the same base, but we have another thing called a cannot be 1, and this is because of the function property. So I'm going to talk about that later in functions, okay? So we have this, and then 7, so important thing. So if we have a to a, we have 1. Because a to 1 equals to a, right? A to 1 equals to a, that's why. So using this, we can prove it. So a to a is 1, so we can make y over n out, and then y equals to n times log base ax, okay? 8, we have, alright, so in the case where we don't like the base, then what can we do? Then we can change the base by writing as in a fraction. And why does this work? So for HO students, you need to know this proof. So let's say log base ax as y. Then change it to exponential. We have a to y as x, right? Then what we can do is that we can try to make these as a power of another number. So for example, if you have like 2 squared equals to 4, then we can make it as 2 to 2 to 2 as 2 to 4, right? Because that's the same. And we can take log base c on both sides. So like this, we can take, so if we have 2 to 4, then it's clearly fine to take natural log, not natural log, log base 2 or log base something, both sides, okay? So we have this, and using this fifth property, what we have for this is y times log base ca equals to log base cx. So y equals to log base cx over log base ca, okay? So this is the proof for this. And what we can do is that we can also write this as 1 over log base xa, because c here, it can be any base, which means that we can let c as x, right? Then log base xx is 1, right? So 1 over log base xa. So if you want to switch them, then we can make it like that, okay? So that's it for the properties that we learned. One additional thing is that using inverse function properties. So if we compose inverse with original function, we have x. And if we compose the inverse with the original function, we still have x. That means let fx be log base ax, then f inverse will be a to x, as I said, right? They're in inverse relationship. So f of f inverse, that means we have inverse function as an input of the original function. So that means we have log base a to x as just x. And it clearly makes sense because, so for this one, we need the inverse property here as just simply y over n, okay? So, or we can, using the properties that we have learned, we can take x out, and we know that log base a is just 1, so it's just x, okay? A bit harder thing is the other one, so inverse with the original function. So if we have inverse we have original function as the input, and that becomes a to log base ax. And if you have something like this, that means it's just x. Okay? What can we do with this? Then, for example, if we have e to x, we can change it to, so this 2 here, we can make it as e to log base e2 x. So we can write it as e to log 2 times x. SL students, you may not really need this a lot, but for HO students, you will need this a lot in complex numbers later. Okay, so that's it for log properties. And again, let's try a very simple question with log equations. So solve for x. Then again, we have log. So so far we have been solving polynomials, right? So we can try to use substitution as what we did for exponential, but seems like we don't have a common subject because we have base 2x and this one is base x2. But we have learned another one of the log property that if we can switch the base with the value, we just put a reciprocal, right? So that one, this equation can be written as this. That means now we can let log base 2x be a. Then we have a plus 3 over a minus 4 equals to 0. And we can multiply a on every side. So a squared plus 3 minus 4a equals to 0. That means a minus 3 and a minus 1. So a equals to 1 or a equals to 3. So log base 2x equals to 1 and log base 2x equals to 3 and x equals to 2, right? 2 to 1 and x equals to 8, 2 to 3. But for some other case, for example, like you take the same step and let's say you have a as for example so log base 2x as 0, let's say, and log base 2x as alright, so let's consider this case first. But yeah, so let's say you have x as like -2 and x as 1. Let's say, for example, then for these two values, you have to check whether it makes sense or not. So x equals to 1, that means you try to put in here. So 1, it's absolutely fine, right? But x is in the base, and can we put base as 1? As I said, we can't. We cannot. And we cannot because we need to understand the function later. So you can watch the videos for function for the reason why the base cannot be 1 for log. So this one, we have to reject it. Okay? And also this one, can the inner value of log be negative? Because remember, this inner value, this input, is the exponential value, right? The exponential value as this, a to n. So that simply means a to some other base with the power equals to -2. And does that make sense? It does not make sense, right? Because we only consider the base is positive. So every exponential value must be positive. That's why we have to reject this too. Okay? So this is very important, so that whenever you have the values out, don't stop it like quadratics, okay? That's not it. You have to check whether the values are valid or not, okay? So that's it for log and exponential. So it's a very simple topics, and but for log properties, I understand that some may find that very like not yet familiar, so a bit confused with the other properties. So do a lot of practices, okay? And hopefully you'll be fine. And please remember the definition, okay? So yeah, that's it for today, and bye.